So welcome back. Now we're going to continue on the right-hand side of assignment statements and talk a little bit more about some complexity about what you can do with these expressions. So all programming languages have various operators where you say, x plus 1 or x minus 1 or something like that. These operators historically come from the kind of characters that were on computer keyboards in the 1960s, literally. These things called teletypes came from the end of World War II, and they had a certain set of characters. And we were going kind of from mathematical character set, where multiplication is a big cross or a dot in the middle, and exponentiation is raising a little tiny number above it. And we just couldn't represent those on these really rudimentary key punches or rudimentary terminals. So we had to map mathematical formulas and functions into what could be done. And so those keyboards from, 40 years ago, 50 years ago, they had a plus on it, so plus is a plus. They had a minus on it, but multiplication, which is normally cross, is star, and division, which you can't put things on top of one another, so you just made a slash for division, and raising to the power is double star. Now, the remainder operator is something that's not typically on calculators, but it's really important for computers, and we'll take a look at this. So the addition operator, pretty straightforward. I've kind of been using that without even talking about it. The multiplication and the division. So this is 5,280 divided by 1,000, which gives me 5.28. But the one that's probably the most interesting is this modulo or remainder operation. And so the way the remainder operation works is, in particular if this is an integer, is it does the division. So it's almost like a division, j divided by 5, but instead of giving the quotient, this is the quotient, it gives the remainder. So 5 divided by 23 is 4 remainder 3. The 3 is what you get back. Now you might ask yourself, why is this useful? So one of the ways to make this useful is to pick a large random number and then use the modulo operator, the remainder operator, with 52, and then you end up with a number between 0 and 51, and then you can pick a card. So you can take a random number, but you modulo at 52, and now you can have a random number that is a card. Or if you want to roll a dice, you make a big random number and you take it modulo 6, and then you can it tells you what side of the dice. So like games and stuff. There's other situations where you can do even and odd calculations, like is this an odd number, an even number, divide it by 2 and see what the remainder is. And so this whole notion of the modulo operator, it's really useful in some situations, and so that's why we obsess about it a little bit. The power operator, this is like 4 times 4 times 4, which is 64. So those are the numeric expressions. Now, these also have an order of evaluation, and the way it works is in mathematics, there's order of evaluation. There are some operators that are more powerful than other operators. And you can always, if you're clever, just put parentheses in. And most programmers always put parentheses in. So if I was writing this line of code and I want it to be friendly to you so that you could read it more easily, I would simply put the parentheses in for you. So I'd say 5 to the 6th power goes first, then this 4 divided by that goes next, then this 2 times 3 goes next, and then we evaluate the rest of these things left to right. So I just added the parentheses that are the same. This is exactly the same as what it would be without the parentheses, because this happens first, this part here happens second, this happens third, and then all this other stuff happens fourth. So there's an order. But we're going to teach you what the order is if you weren't going to use parentheses. So the rule is parentheses override everything. Exponentiation is the most powerful. Multiplication and division and remainder are equal. They're the next most powerful in addition and subtraction. And then when in doubt, you just go left to right. So if there's a bunch of additions, you just go left to right. Or if there's an addition and subtractions and a bunch of stuff, you go left to right. Okay? So this is a classic exam question on computer science homework that you just say, okay, what does this evaluate to? Now, of course, if you have Python, you just type it in and it tells you what the answer is. So the way I used to do these back in the day when I was doing these homework is I would write the expression down on a piece of paper, and then I would look through it and I would figure out what the first thing was, and I'd be very careful about this. I'm like, okay, exponentiation happens first, so I'll do the 2 to the 3rd power, which is 8, and then I'll rewrite the whole thing. 1 plus 8 divided by 4 times 5, and then I would forget about this one, and I'd look here, and I'm going like, okay, what's the first thing here? Well, 8 divided by 4 is the first thing there. So then I'd be like, oh, 8 divided by 4, well, that gives us 2. In this case, it gives us 2.0. And then I have 1 plus 2.0 times 5, and I look, and that's the next one. So that ends up being, actually, this ends up being 10.0, and that ends up being 11.0. And that's why this prints out 11.0. And so if there are no parentheses, you can figure out. Another kind of exam question is to ask what the parentheses would be. So the exponentiation happens first, the division happens second, and then actually you'd put another parenthesis because, you know, that result is multiplied by 5. And so that's another way to kind of answer the same question, is say, put the parentheses in where they belong. Like I said, parentheses first, power second, multiplication third, addition, and then left to right. So when you got nothing but addition and subtraction, you go left to right. When you got nothing but multiplication, division, you go left to right. Start with the leftmost one. Sometimes it doesn't matter, but in addition and subtraction, it generally doesn't matter. But in multiplication and division, it can matter left to right. Okay, so we've been talking about variables, we've been talking about constants, we've been talking about expressions, but we also have constants that are integers, we have constants that are floating point numbers, and we have constants that are strings. And we can manipulate these. And Python carefully tracks not only what the value in a variable is, but what kind of a value it is. So is it a string? Is it an integer? Is it a floating point? And sometimes this makes a difference. And here's a little example code. We have this plus operator. And the plus operator is looking at its two operands, 1 and 4. It's like, oh, those are integers. I know what to do with integers. That means addition. And so it adds this to be 5 and then sticks it into DDD, and out comes 5. On the other hand, we can actually use this same plus operator concatenating strings, because the plus operator looks to its left, looks to its right, says, oh, those are strings, and I know what you mean. I think you mean to concatenate this. And so then we end up with hello. The space is very carefully constructed right there because the plus doesn't add a space. So this ends up being hello space there, and that little space is the space here. And so Python knows the type of, in this example, these are all constants, but it knows the type of constants and it knows the type of variables, and it can do very different things. And it can blow up and be unhappy, as we'll soon see, based on the type of things. So here we have an example of something that's unhappy. So I have now concatenated hello in there, and then Python's perfectly happy to do that, and then I stick that in EE. And now I say I want to add 1 to it. And it looks to its left, looks to its right. This is a string, and this is an integer. And Python says, I don't know how to do that. Python could know how to do it, but it's chosen not to know how to do that. And so you get the dreaded traceback. And traceback is like syntax error. It is Python telling you, it's not Python telling you that you're a bad programmer or that you're never going to be a programmer or that you're completely unsuitable for a programmer. What Python is saying is, I, Python, am lost. You told me to do something I don't know how to do. You need to go remember what it is that I'm capable of doing as Python. Please come back and fix it. It also means that the program stops, meaning that if you're in a multi-line script and you're doing a bunch of stuff and there's a traceback here, the code after that quits, okay? And that's because you've hit this line that Python is lost and Python is loath to continue. Now, we'll see in a bit that you'll be able to force it to continue if you want, but because you said something that Python didn't understand, it just quits at that point. And traceback, line 1 in this case, tells you where it is that this thing blew up. And so this looks like nasty gibberish, but after a while, it won't take you long at all to just relax, look for the word traceback. That means Python quit somewhere. It tells you where, and then you look a little bit farther, and it tells you what's wrong, type error. It's unhappy with the type, and it's still referring up to this line of code. It says, I can't convert integer objects to string implicitly. So it's like you have told it to do something, combining a string and integer, and Python is like, I am lost. But I'm giving you as much clue as to how I got lost, what got me lost, where I got lost, where I got lost, and what caused me to get lost. And Python is trying as hard as it can to